I just want to record more stuff. It's so exciting to me, and I cannot wait to record more with this technique.
Hello, I'm Hyun-Kook Lee. I'm a professor in audio and psychoacoustic engineering at the University of Huddersfield. I lead a research lab called Applied Psychoacoustics Lab. I've been researching spatial audio, immersive recording, reproduction techniques, binaural audio over the last 25 years. And I'm really excited to be here with Andrew today, and thanks for the opportunity to speak about immersive audio.
And I'm Andrew Scheps, producer, mixer, own a record label, lots of things to do with making music. And I first met Hyun-Kook, I don't know, 5 years ago?
Something like that.
Something like that.
Yeah.
And I've been absolutely fascinated in the immersive recording techniques, because as I'm doing more and more immersive mixing, getting source material that will work in that format without having to manufacture everything has been a big part of my sort of journey through it.
Yeah, also we met last year at the AES International Conference on Spatial and Immersive Audio, where we had Andrew as a keynote speaker, and we also had a panel discussion. And that's when actually Andrew listened to my organ recording, the recording from the concert we had on the first night. And I remember Andrew saying that actually the recording sounded better than the actual concert hall sound. So I was super excited at the time. And so that's how we actually started talking about immersive recording.
Yes, the organ recital, the first night of the conference, your PhD advisor, who's now a full-time organist, gave a recital in the Huddersfield Concert Hall, which is a converted church. And it sounded amazing. I mean, an organ in a church always sounds amazing. And Hyun-Kook was recording from sort of the middle of the church, and we were sat further back.
Yeah, right.
And there's a thing about a church organ where the low end is so visceral and physical, and it wasn't. I'm watching the feet hit the pedals, and it was like, oh, there's something low. And then when we listened back to the exact same recording, just mapped channel to speaker, no processing whatsoever, it was breathtaking. The low end was just absolutely amazing. And I think part of it was probably where you were in the room, but part of it is also, when we can talk more about the array in a second, you'll do that. But having that many coincident microphones that are completely correlated because of the way the array is set up, the low end in all of the microphones adds up perfectly. So you end up with this beautifully distributed low end. So even using different patterns on the capsules doesn't change the low end, because everything's omni down that low. So you ended up with this unbelievably coherent low end. And for me, I love low end as an intellectual exercise, but it's just the power and the emotional response you get to the pedals on a church organ was there in the recording in a way it wasn't in the room.
There's an AES journal paper I wrote. It's a review paper that summarizes all of these existing immersive recording techniques with height. So, the surround mic techniques have been developed since mid-90s from 5.1 days. But then with height, the question is, how should we arrange the microphone for the height channels? So the traditional approach is having spacing between all of the microphones. Then I came up with this idea, so our ears are always horizontally spaced, but then everything from above is picked up at one point. So do we actually need the spacing? Back in 2013, actually, I did some experiments about the effect of microphone spacing on the spatial impression. And we found that none of these spacings made any difference. So 0, 0.5, 1 meter, 1.5 didn't make any difference. So that was actually the beginning of designing my own array, actually, PCMA 3D. Actually, it was originally a 5.1 array, just one microphone pointing forward and the other microphone pointing backward. So I can actually mix these two signals to create like a virtual zoom in and zoom out effect. So you have more ambience if you stir the microphone towards the back, Or if you make it forward, then you get more direct sound. So that was the purpose. But after the experiment in 2013, I realized I can actually just angle it more upwards. So you can actually pick up the main sound and the height at one point, just like our ears capture the sound. So that's basically the PCMA 3D. Then there are other techniques, like Morton's wonderful Omni-based 12 cube, which captures a lot of like decorrelated ambience, which works really well in a large, diffuse, well-treated, like cathedral type of environment. And also there's ambisonic, as you know, it's a one-point microphone technique that captures signals from sounds from all directions. But then you need to decode the signals to specific speaker arrays. There are a lot of pros, advantages of ambisonic microphone recording, but the downside is that you need to sit down right at the sweet spot. If you move slightly, then the cues are broken and you cannot really have the same sort of amount of envelopment. And the sweet spot is such an important thing in music listening, even for one person, because we are not staying at one point all the time. We always move. So yeah, basically there are three approaches. I would call them horizontally spaced, vertically spaced, and horizontally spaced, vertically constant, and horizontally constant and vertically constant. So three main different kind of techniques. Okay, so PCMA 3D is a flexible technique, but the important thing is concept. So it's a horizontally spaced, but vertically constant array. So LCR, it can be arranged in various widths, but I usually go with 1 meter. So then your left, center, and right microphones, they can be cardioid, wide cardioid, could be even omni. But with the cardioid, you need about 45 degrees subtended angle from the zero. Then you have a center microphone placed at about 25 centimeters from the base point. So you have like this LCR tree in front. And then the rear is placed about 1 meter from the base point. And the microphone can be cardioid if you want to capture more of a warm sort of reverberation from the back of the space. Then cardioid facing backwards or slightly outwards, that works well. But if you want to capture more of a bright, sort of like a lateral reflections and sort of bright sounding reverb, usually, I place supercardioid facing sideways. And then the side channels for 714 could be simply side facing supercardioids. For the height channels, PCMA 3D version 1 is a constant technique. So I usually use CCM41 or MK41 supercardioid pointing directly towards the ceiling, arranged constantly with the main microphone. So the advantage of this is it's super easy to fold it down to 5.1 or stereo. You don't actually add any tonal coloration other than the reverb just added to the signals. So you can actually change the DR ratio even. If you want to make your recording more distant sounding, you use more of the ambience. If you want it to be more close, then you use more of the main microphone. So it's a very flexible technique and it's a flat array, so easier to set up in live settings. And then, ORTF 3D shares the same philosophy. It's a horizontally spaced or vertically constant array. But if you want to record an orchestra with omni microphones for the LCR, then you need to apply a bit of spacing for the high microphones, but it doesn't have to be super high. It could be just about 25 to 30 centimeters. That's good enough to, create some sort of decorrelated sound field. Yeah. So the main purpose was to capture the spatial impression as naturally as possible. So for that, the first thing to think about is the amount of direct sound captured by all these height microphones. Because if the height microphones capture too much direct sound, which I call vertical crosstalk, then when you listen to all these direct sounds, the ears actually receiving all these signals with the delay times involved. Then you know what happens, the comb-filtering happens, and you get coloration at the ear. So that means we need to actually reduce the amount of crosstalk to some extent. Then the question was how much we need to reduce. So from my listening test, I found that at least about 9 dB should be reduced. That means you can just simply arrange your cardioid microphone facing upwards or slightly angled upwards, so you get, off-axis reduction. But then if you have a supercardioid, you can just point them directly towards the ceiling, and you get the null point around 120 degrees, so you get a really large amount of channel separation. Then it gives you more of a freedom to change the level of the height channel. So if you want more of a spatial impression, you can raise the volume. It doesn't interfere with the localization of the sound sources. It doesn't really color the sound, but it just increases the overall ambience. And so that was basically my main philosophy in terms of microphone array design.
The thing about the technique is instead of feeling like, okay, I want to record this source immersively, I want to capture the space and the performance immersively. And that's what you do as a listener. You stand in one place. So the idea of putting microphones behind an orchestra is crazy to me, and it's never made any sense because that's not where anyone is listening. It also, in an orchestra or even in a drum kit, completely changes the balance of the instruments. So it's not anything you actually want to hear. Whereas what works so well in this technique, the mics are basically coincident and just far enough apart to give you the separation you need if you're not going to use hypercardioid or supercardioid everywhere. But you are getting one perspective, so you are recording the space and not necessarily just the performers. And what it's allowed me to do, and the huge surprise I got, because I thought when I recorded the string quartet on some productions for a band called Low Roar, was that I would have the front microphones to use for the stereo version of the song, and then I would have the rest of the microphones to bring in for the immersive version. And instead, there are parts of the arrangement where the height microphones on their own are an amazing ethereal sound for the part of the arrangement that is all harmonics, where it would be almost too dry and direct, and then you would put reverb on. So you have this unbelievably coherent sort of impulse response of the whole room, but it's made for the performance you just did. So you can mix and match these channels, and you don't have to pan them when they're supposed to be. You can combine any sets of microphones together, and it works perfectly. So I could actually make decisions in the stereo mix about how ambient I wanted things to be just by mixing and matching microphones. It was really extraordinary, and it never even occurred to me that that's what I would be doing.
Exactly, that's basically the beauty of this technique. So if we have enough separation between the main layer and the height layer, they're capturing different elements from the room, different so the harmonics from the instruments. Actually they are developed from the ceiling. The ceiling reflection actually adds a lot of realism in what you hear in real life. If, for example, if you imagine that all the ceilings are treated with absorption panels, so you have an anechoic ceiling, and suddenly something's missing. We never realize in real life because we hear it all the time. But when you are missing the height information in real life, it's going to sound really strange. So actually in musical performance in an acoustic space, capturing the height is so important. But then that shouldn't interfere with the tonality of the instrument, and it has to add up really naturally.
Yeah, and it does. And the other thing that I've noticed in some test recordings, so it didn't come up with the string quartet, was that because you have the height information, it actually gives you localization below the plane of the main microphones,
right,
because it won't be in the height at all. I mean, the example was, I have a recording of my wife walking in a circle, whistling, and our cat came over because there was someone whistling and started meowing, and you actually hear the fact that the cat is below the microphones.
Even if the speakers were in the
so the
level.
speakers are head height, the microphones were head height, and it sounds like the cat is below because there's nothing in the hypercardioid height microphones. Whereas if you're in the plane of the microphones, obviously you will get things bending into those height mics. So I think what was astonishing was the flexibility. And I have to say, using the Schoeps microphones that we're using, the ability to swap out patterns and change angles, but within this array, you don't have to think about, well, if I angle the microphones, is it still coherent? Do I move? You never move anything. You do it with angles, you do it with pickup patterns. Because I was going to ask, actually, do you ever feel like you want to make it a 2 meter by 2 meter array? But I can't imagine even needing to.
Actually, I've done a lot of experiments in terms of the width and depth and height, and we actually have impulse responses for all of these different combinations. So I found that horizontally, of course, if you're recording a large orchestra, 2 meter can actually benefit from the space decorrelation between the signals, and that makes basically sound more wide and spacious.
Yeah.
But then for most cases, 1 meter array actually is more practical, and also it actually, you mentioned about the low frequency coherent,
Yeah.
that kind of impression. It's actually comes from the 1 meter width.
Exactly.
Because if you spread the microphones too largely, then the problem is that you don't have that much coherence, in the low end, and it's about 200 hertz below. They inherently have high correlation between the ear signals, and we cannot really make it even more decorrelated. So the ear signals below 200 hertz, they're always very correlated. So you cannot lower that unless you increase the spacing by like 3 meters or something like that.
Right.
Then I compared all of these different configurations, and I found that 1 meter actually gives a more intimate kind of sound in the low end, whereas you have enough spaciousness and envelopment in the mid frequencies.
Right.
That is important for me. So for like organ, if it was too large, then the low end might have sounded a bit fuzzy and a bit weak, So
because you were capturing such a large instrument in that particular room, in a very large room, it was wide cardioid instead of cardioid, right?
Exactly,
On the left and right. So the ability to mix and match, and also just on a practical thing, with 1 meter, 3 1 meter microphone bars, you only need 3 microphone stands, and you can get all 11 microphones on there perfectly.
Yes, and the reason why I used wide cardioid is because of the low end response. Because organ is such a big instrument,
Right.
so we want to capture more of the organ. You could actually use Omnis as well. But then I would go with the PCMA 3D version 2, which is actually what you used. You had some spacing, right, between the main layer and the upper layer.
No, the height microphones in the same plane.
Oh, same plane.
Same
Okay,
plane.
so that's version 1, basically. That's the original PCM 3D, which works well. Then when I did the organ recording, I placed a little bit of spacing because it's about harmonic reconstruction, because the organ is such a large instrument. So it's not about ambience anymore, because
Right.
you capture direct sound from the organ. So depending on the spacing, you get different tonality. Which is really interesting.
See, now I have to experiment with that.
Exactly.
I love to have a solution, and it's done. But,
So then we can use like Omnis CCM2H, like diffuse field equalized Omni capsules. Omnis work really well with orchestra always, because you
Right.
want to capture more of a low end. But then again, for the height layer, supercardioid works just perfectly, because you have different elements for the height channels, and you can mix and match them as you like.
Yeah.
And they're super flexible.
Yeah.
But in terms of depth, actually, I found that you don't even need 1 meter sometimes.
Right.
Yeah, 50 centimeters is just fine in terms of decorrelation.
You're not supposed to tell me this. It's 1 meter. It's always
One
1
by
meter.
one always works.
It does, though.
But
It
if you
does.
want to, make it even smaller, you can actually go even closer. But again, the important thing is about channel separation. The front and back needs to be separated enough. So like cardio is facing about 135 degrees backwards. It works well. But depending on the acoustics of the space.
Well, exactly. In a drier room, you would point them even further back.
Yeah.
So you get...
But sometimes some rooms have got horrible slapback echo from the back wall. Then if you have a cardioid backwards, it captures all the slapback echo,
Right.
whether you like it or not. But then you can also use a supercardioid facing sideways. Then you get more of the wall reflection.
Yeah.
It could be beneficial.
Yeah,
as
it's
well.
so flexible.
Yeah, so flexible. Yeah. I think I've got about 25 Schoeps capsules, and I can choose whatever I want for different types of recordings I do. And yeah, I mean, the most important thing about Schoeps mics is the tonality, the tonal balance. It doesn't sound overly bassy, it doesn't sound dull, it's just spot on. It has got a musical sound. If I record the strings or anything, I don't have to EQ anything. It's just basically usually I just use the original signals. I don't even have to do high pass filter or anything like that. It's got superior quality, very pure sound, neutral sound, which I like. I like neutral sounding recording. So yeah, that's the main reason why I go for Schoeps. Yeah.
Just on the practical side, especially with the Colette, they're tiny. I have what basically is something that looks like a pencil bag that has all 11 microphones in it. So it's very, very portable, which is big for me. I need to be able to set it up quickly and in places that would be a problem with other microphones. Even as you change patterns, the tonality of the capsules is so consistent. That is huge as well, because otherwise you don't want anything that you're going to have to compensate for that is not part of what you are recording. And if any of the recording apparatus has variances, then you don't even know where to start. And as soon as you start messing with it, then all of this coherence goes away, and a lot of the benefit of the mic technique itself goes out the window. So the microphones are so consistent, and I don't hear a tonality difference when you're head on. Every single pattern I've heard, it's the same. And then if you want to treat it, you can, but I have yet to EQ anything I've recorded with them. It just sounds like you're in the room. And that's not, you could say, oh, well, maybe it's a boring sound. It isn't. It's a very exciting sound, but it's very present. And in a way where if you do a Decca tree with old tube microphones, M49s, M50s and things, it's a beautiful sound that we've heard before, but it's a very, very affected sound. People think of it as being very natural. It's nothing like what you hear in the room. And it's very sweet and all of that, but I feel like you have this starting point that's easy to get, that you could do anything with, but as of yet, I haven't had to do anything. It fits in perfectly with every track I've used it on.
Same as my experience, yeah. I don't need to EQ or anything like that.
No, I did a high pass filter, but it's because there was an air conditioner.
Yes. I've used this Schoeps mic since 1997, I think. I think that was the first time I used the Schoeps mic. It was a CMC6 preamp with MK capsules. I loved ORTF and all so. But then when you introduced the CMC1, that was a real lifesaver because I do a lot of location recordings. You sometimes hang the microphone from the balcony or ceilings, and the microphone should be small enough. Otherwise, video guys hate it. They don't want microphones to get in the way. So, yeah, the small capsules really save time and setup time as well. You don't actually have to do a lot of cabling because the microphone comes with a thin cables, the CCM4, and those thin cables are really invisible. So it's a really nice, clean setup I can make. But then the preamps actually sound exactly the same. Whether you use CMC6 or CMC1 or CCM4, they all sound the same. So that's really impressive. So as Andrew said, the consistency is really important, especially in stereo or surround recording. You don't want your left and right microphones have got different balance or tonality. So the consistency has been a very important factor for me.
And I think also the small form factor is huge because you're trying to get things coincident, and you can't do that with just microphone bars if they're big.
Oh yeah, definitely.
And the capsules are so small and the amplifiers are so small that it's very easy.
Yeah, and also if you want to put them in a cage, windshield, it's very easy to actually put them in a Ryko or anything like that. So
I mean I just feel lucky that you get the two things in one package, because otherwise you would have to choose. You would have to say, okay, these microphones sound great, but logistically they're impossible, so we'll go with these microphones. But there's certainly no compromise being made.
And the great thing is it's modular, so once you have a whole set, MK and CMC body, and then you can just swap the capsules. So I can actually vary the combinations. I can use CMC1 with the MK4, or I can use CMC6 with the other capsules. So it's super flexible.
It's cool. Amazing. And also, I did want to mention that I'm using the DAD AX Center as my mic pre. So the entire rig, if I'm carrying everything, including cables, I have one backpack that has all of the microphones, all of the small stands, all of the pop filters, all of the mic clips. I've got a little carry-on bag that has all of the audio cables, and I have a one-space rack on my shoulder, a laptop, and 3 mic stands. I can literally
Really
carry
compact.
the whole setup
Yeah.
at once.
Yeah.
It's a little heavy with the cables, but yeah, it's, and what that means is I can just go record anything I want.
Yeah.
And it sets up in, realistically, 15 minutes. I could have it set up now that I'm practiced at it.
So for me, my experiment continues. I've been experimenting with microphone configurations but since my PhD actually. Even before my PhD, my first sort of surround recording started in 1999 actually. When I did my internship at Aspen Music Festival in Colorado, there was a lot of 5.1 microphone technique experiment was happening. But then now I've done a lot of recordings with the high channels and a lot of experiments, but I still feel the need to do more, to explore the possibilities of immersive recording, especially in a pop rock context. Because there's a lot of recordings I've been making and other people have been making in classical recording, immersive recording since even before Dolby Atmos came along.
Yeah.
Since about 2009, 2010. People started experimenting with the high channels, but it was all in classical recording field. But now that there are more interests in immersive recording in the pop and rock, I think there is a lot of opportunities we can create with them. Maybe different kind of configurations might work for drum recordings. Actually, PCMA 3D can be used for drum overhead. I use the same concept, basically vertical constant array, but spaced at 2 positions. Like a conventional,
Right.
cardio is pointing down to the cymbals, but you add 2 more microphones facing upwards.
Right.
And then you can have a really nice down mix as well. And then you can change the ratio between the two, and it's really cool. So that kind of experiment, I'm really keen to do more, in different musical contexts. Yeah, and also I'm very interested in creating high quality educational resources. So yeah, exciting times.
And I think that one of the things that maybe this crossover into more pop and rock recordings is that it's been seen as just an orchestral technique. And I don't think people understand that you can mix and match. It's not like you need to be producing for immersive, recording everything in immersive. These string quartet recordings I've done are for a very traditionally, well, it's not a traditional band, but there's nothing immersive about the production other than the recording of the string quartet, and it fits in perfectly with the rest of the recording. There's no compromise or anything like that. So to make people start thinking about mixing and matching the techniques, it's just like you set up microphones differently for every instrument. Sometimes those choices will be an immersive array as opposed to a mono or a stereo array. And I just feel like that will become more and more prevalent.
Yeah, definitely.
So I just want to record more stuff. It's so exciting to me. I've been doing this for a long time, and some of it can be not, it's not that it isn't fun, and it's not that I don't love doing what I do, but it's not new. And it's not exciting in the same way. And I cannot wait to record more with this technique. It's amazing. So yeah, I don't know exactly what I'm doing next, but I'm looking for things to record. It is that exciting. Anytime I'm in an acoustic space now, I wish I could record that way. There'll be very few things other than like a vocal or something like that where I wouldn't use at least a scaled down version of this array.
I really value that scientists and artists work together. That's how we can actually make something new, push the boundary. Scientists do need to understand what artists need, and artists can also benefit from scientific research. So we can actually make something together, and that's been missing for many, many years. And that's what I'm trying to do. Trying to bridge the gap between the creative world and the academic world. So this is exactly what we're doing here with Andrew,
Yeah.
and it's great. Yeah, it's massive impact we can create together.
And I think for me, I will always see what people are doing and I'll hear something and think like, oh, that would be great. I'd love to do it. But when you're looking at the way like other mixers work, like Chad Blake is one of my heroes, if I try to use plugins set the same as him, it doesn't work at all. And what I love about working with you is that you don't do it, oh, it's just the thing I do. You do it because you've tested 500 other things and this is the thing and it's all repeatable and provable. But you are also a great engineer with great ears and you listen for the musicality of it. It is not just graphs, but it's all backed up with actual science. And for me, being a geek, I love that because I feel like the more solid it is theoretically, then the more you can just mess with it. Otherwise, it's so fragile that if you don't get it exactly right, it all falls apart. And so what spurred this was not me just wanting to do something interesting. It was the organ recording.
It's great. So I mean, you see the value of academic research and then how it can be applied in practical work. So I really appreciate that. And working with you, gives me a lot of insight, practical insight. What we need to do next, to develop something new. Then we need to get inspiration from content producers. You're also very academic, and you're also supervising our PhD students together. So we can actually share a lot of thoughts together, and that's, I think, where the synergy is, if we just talk with what we're doing all the time, if we just write paper and then just stuck in our lab and just we know how good it can be, but it's never being used in the real world, and it's not really good.
No, and then to have it be so emotionally brilliant when you use it is, it's a dream. It's great.
Right.
Shops.